In this, I will talk about service-oriented architecture. The agenda of this session is a flashback to our previous session where we talked about TOGAF and enterprise architecture and its relation to this session's material. I will then talk about service and the nature of service. Then I will explain what the SOA or service-oriented architecture is, and then I will move on to the principles of SOA, and then at the end I will talk about the application of SOA in enterprise architecture. If you remember from the last session, I talked about how enterprise architecture frameworks can help enterprises and businesses build their own enterprise architecture using certain frameworks, standards, and also provide them with some building blocks, pre-built Lego blocks in order to use in their process of building enterprise architecture. We also talked about how, as we go through an iteration of building those our own building blocks, we can store them in a content framework, which we called it solutions continuum, as you can see here. Solutions continuum, and within that solutions continuum we store our own building blocks and we use them as we go along. Then I explained how we can bundle together different services from the pre-existing building blocks in our content framework and solutions continuum, as well as the architectural continuum, in order to build our own layers of services. And I explained how those layers can be formed in terms of information layers, business layers, and composition layers, as well as infrastructure service layers. And we explained how this represents our actual architecture, and whereas this represents our enterprise meta architecture. As per our discussion, we can see how the layering of our services can look like this. This layering means that we are wiring different individual services together in order to create a higher level or higher value complex services, or in this case we should probably call it business processes. This means that we use our individual services, in this case the activities and tasks, as well as applications and data that are sitting on top of our infrastructure that provides our, for example, operating systems, as well as database or DBMS, database management services, and so on, that can provide the facility of data and operations to our own applications throughout the organization. And then we can use those applications and the data to create our service interfaces, and then bundle together all those service interfaces in order to create new complex services, or in other words, business processes. Let's see what is a service and how we define services. As I explained before, a service is a component of distinctive functionality, meaning that typically encapsulates a high-level business concept. So from a business concept is basically a operation of a business operation that does a simple individual thing. And that's what we call a Lego block or a building block of our enterprise. So this building block would also depend on the data and operations and applications that we have as its underlying implementation. A service also contains a contract. That this contract is a message that defines the type and the constraint and the description of the service. It also provides an interface that sets the operations, basically tells the user or a service user how to use these services and what kind of operations the service provides. And of course, it will have an underlying implementation that it depends on the logic and the data that the organizations provide for this service to exist. Now let's see what is service-oriented architecture. So basically, service-oriented architecture is a software architecture model that which is a business functionality that logically grouped together and encapsulated into self-contained and distinct and reusable units that we call services. These services represent a high-level business concept, for example, an invoice or a sales, and then we'll talk about how these services can be complex or basic. It can also be distributed over a network. That means when an enterprise have a whole bunch of multiple different services, it does not have to keep them all in one place in order to make use of them. So basically, this is one of the very, very good and popular advantages of service-oriented architecture, where you can actually put or find different services in different areas of your network or throughout the internet. It can also be distributed, of course, as well, and then we could what also need to be is to be reusable and also be created reusable. So this reusability or creating a services with reusability in mind is very important in order to create new business operations or new business applications, because we later we will find out we need to be able to create new complex services by using more simpler or basic or fundamental building blocks or perhaps basic services together in order to create more complex operations and business processes. It also has to be able to contain a contract with specifications of its purpose, functionality, interface, constraints, and usage. In other words, services are autonomous, discrete, and reusable units of business functionality that are exposing their capabilities in form of contracts. Services can be independently evolved, moved, and used in runtime. Now let's see how these all get together. In a service-oriented architecture, we have different layers that provide different types of services. At the top, we have a collection of services. This collection of services is basically what represents a business process. So a business process here represents, for example, a sales operation. So for example, in sales operation, you may need different types of services, such as finding a product, pricing a product, ordering a product, and so on, until an invoice is actually issued. These type of operations are possible by using different layers of functionality that are exposed as services. For example, we have services as a business services, and then on below that service we have another layer that exposes the services as data services and application services, and at the bottom we will have infrastructure services that could probably provide operating system, a network, and data database management systems or services. Now a little bit of history of how we actually got here and how we got into acceptance of service-oriented architecture. Before, applications were developed in enterprises in different using different frameworks like tiered application and multiple tiered applications. The most famous types of legacy system was three-tiered architecture. In this three-tiered architecture, we had things such as the presentation layer, the business logic layer, and a data layer. We separated these layers in order to achieve separations of concerns, therefore some degree of reusability, to achieve some degree of reusability. These three-tiered architecture had attributes such as homogeneousness, language dependency, and a centralized application tiered. So these tiered would have to be centralized. Whereas when we arrived on service-oriented architecture, we arrived at a heterogeneous architecture where things are not connected to each other by themselves or independently. Instead, every piece of this architecture is actually connected to something called enterprise business bus, which enables different areas of applications or different areas of organization that need different processes or business processes to take advantage of every different component or every different, I should say, service throughout the organization to build their own new complex services. The most important attributes of this new architecture is, as I said, heterogeneous, being a heterogeneous, also a language independent. That means every service does not, the implementation of any service is not really relevant to the use of the service. Therefore, the business user does not need to know which language the service is written of or know any details about the implementation of the service. This architecture is also important in terms of being massively distributed. That means every single service can exist in a different location throughout the organization or even outside the organization. That also brings about another thing which we call flexibility of composite applications, and it's built on the request reply publish subscribe mechanism. SOA is an evolutionary step. That means if we wanted to move from the current architecture into a service-oriented architecture, we cannot do that in a big bang and arrive on service-oriented architecture all of a sudden within one massive project. So it has to be a distributed communications throughout that. So let's say if we wanted to create a distributed application system or a service-oriented architecture from an existing ones. First, we probably think about creating a central distribution system for our individual services. As we say, this is an individual service, this is another one, this is another one, and we wanted to create a connectivity between all of these. Then we create a centralized distribution system that it also starts creating other problems where we have to create a centralization, which by itself defeats the purpose of service orientation by creating a dependency between all the components of this system. Another way of doing this is to completely decentralize all our services or applications and data throughout the organization by coupling these together individually in form of a peer-to-peer connection or point-to-point connection between two services or between two applications throughout the organization. That is also it creates a massive a spaghetti-like architecture that is really hard to maintain and also really hard to understand throughout the organization. Therefore, we come up with a new idea that it's called service-oriented architecture that uses the concept of services, individual services, independent services, and those services could be of type business services, data services, application services, or infrastructure services, that they all contribute or advertise their capabilities into something called a business bus, and then these business bus is accessible by any other parts of the organization in order to utilize and be used or built upon that by building new complex services. Okay, now let's see what is the advantage, or probably how we organize layering throughout service-oriented architecture. As we see on the top, we have our business processes. So these are individual business processes throughout our organization. Every one of those business processes represents a workflow. For example, tax calculation, a sales, or payroll, that they are by themselves complex workflow throughout the organization. Then every one of those workflows may use one or more different composite services throughout our composite service layer. For example, a tax calculator as a complex service, it could be used in both payroll as well as say sales process. And then in turn, those complex services such as invoicing and so on could be broken down into smaller pieces of basic services, and these basic services are really important to be independent small pieces of business logic that only provides one thing, one service, and only provides the simplest type of operation, that it cannot be broken down any further, such as say create an invoice, or say calculate tax, for example. And then, of course, at the bottom of this hierarchy, we have the API of the organization that where our data applications and other types of infrastructure components provide information as well as the functionality to those services directly above them. So 6 important attributes of this organization or service architecture organization are flexibility of composition, and also provides reusability. It provides functional centralization in lower levels. It also provides customization in higher levels, separation of concerns. Policy may vary by different types of layering in this organization. So you may have different policies in your infrastructure layer, or you have different policies in your basic services layers, and so on. Okay, and now major service types. We mentioned some different service types. Basically, we have a basic service type, such as these basic service types or basic services create or provide service-centric and logic-centric services. So basically our smallest piece of business logic put into one box and provides one particular functionality. Encapsulates data behavior and data model, and ensures the data consistency. It provides basic services that are stateless. These being stateless means that service user and service user does not need to know what's happening at the end of the service provider, and there will not be a constant communication or a constant communication established between the service user and the service provider. Basic services represents fundamental SOA maturity level and usually are built on top of existing legacy systems, unless an organization starts from ground up, a greenfield project, then it will not be based on legacy systems. Composed or composite services, they expose harmonized access to inconsistent basic services. When you say inconsistent basic services, that means sporadical. So for example, a sales operation, we view a sales operation as a composite service that will require multiple different services. For example, a search for product, pricing a product, order, invoicing, and also tax calculation. So these components can come together, these little services can come together and create a new composite service for the consumer. Here we can see that idea of service layering and based on the service types. Again, we mentioned before, on the top we have our own business processes. This is one business process that represents a unit of functionality, a complex functionality in our organization. For example, say production. This could be a production business process, or could also be a sales process. This process uses individual composite services. For example, sales composite service, products composite service, and employees, and so on. These services in turn use application layer and they use the functionality of different applications throughout the organization. For example, sales, you could probably use financial functionality, as well as other types of communication, for example, functionality throughout the organization. And these functionality or application layer will use infrastructure layer that provides operating system, network, database management systems, and so on. Now, the biggest picture of everything that we discussed so far is depicted in this, illustrated in this picture that shows everything that we already discussed. First of all, let's look at it from inside out. Okay, so our organization has some business capabilities. For example, sales. Let's look at sales one as a business capability. This business capability provides a particular core API. That core API, such as the sales itself, and that in turn is turned into services, into basic services, in order to provide simple building blocks for that capability. So these simple building blocks will be service blocks that provide the capability of sales for our organization. However, this capability is not all in one place. It is distributed between multiple different basic services, as we mentioned, for example, tax calculator, search product, invoicing, order operations, and so on. And then on top of that, we provide composite services where business-centric services and orchestration of workflows happen. And of course, these composite services are published to public through a portal or particular smart client that would like to use these operations. Now, we will through most important principles of service-oriented architecture here, and then I quickly go through them, and then I will explain them one by one, more details. The first one is a standardization of service contracts. That means every service has to have a contract between the service provider and the service user. This contract has to be standardized, and all services throughout the organization has to provide the same standard of contract. It has to be on top of a loose coupling. That means services should not be hooked up or dependent on each other. It creates a level of abstraction. That means it separates the interface to the user from the implementation of the service inside the organization. It has to have reusability, and that is basically the whole purpose of, probably a big part of the purpose behind the service-oriented architecture. They have to be autonomous or have to be autonomy. It has a statelessness. That means there is no constant communication or constant connection between the service user and the service provider. It has to be discoverable, and so the service users has to be able to discover existing services throughout your organization or perhaps throughout the internet. It has to have a composability possibility. That means that the service has to be designed the way that is possible to be composed in more complex services. All right, so centralized service contracts. What are they? In one sentence, services within the same service inventory are in compliant with the same contract design standard. And that means the services use service contracts to express their purpose, what they are for, or what they do. Also their capability, basically what they are capable of doing. They use formal standardized service contracts. The formalization comes in terms of a technology using things like XML or WSDL in order to the world be able to read them and understand them in a coherent way. They focus on the areas of functional expression, data expression, and policies. Loose coupling means that service contracts impose low consumer coupling requirements and are themselves decoupled from their surrounding environment. So no two services, there will not be, no two services should not be coupled together. That means should not be depending on each other for their existence. That's why we say every service has to be a simple unit of operation depending on only itself. Abstraction means service contracts only contain essential information and information about the services limited to what is published in service contracts. And therefore, any service would not necessarily or would not expose any underlying implementation details to the user or in any abstraction level. It avoids the proliferation of unnecessary service information. That means it's not providing anything such as metadata and so on. It hides as much of the underlying details of the service as possible and enables and preserves the loosely coupled relationship between the services. Reusability is described as a service containing and expressing agnostic logic and can be positioned as a reusable enterprise resource. So it should be agnostic towards the underlying implementation as well as the environment that surrounds the service. So the surrounding environment should not, the service should not depend on its surrounding environment and where is deployed. Autonomy means the service exercises a high level of control over their underlying runtime execution environment. That means no other services or no external influence can change the course of the execution of an individual service. So it represents the ability to service to carry out its logic independently of outside influences. And that is to achieve these services. Primary benefits are increased reliability and behavior predictability. That means when you know how a service works and you rely on that knowledge. Statelessness is about service minimizing the resource consumption by deferring the management of the state information when necessary. That means a service manages its own state and it does not share it with the other components, other services, or perhaps the service user. The goal of that is to increase the service scalability and the support design of agnostic logic and improve the service reusability. Discoverability means that the services are supplemented with communicative metadata by which they can be effectively discovered and interpreted. We use technologies or descriptive technologies such as WSDL that are based on XML technology in order to publish services to the public, and then in directories such as UDDI, and those service users or service consumers can find services by using those directories. Just like yellow pages and white pages, you can find different businesses as a consumer. UDDI also provides directory to find particular services when needed by the consumers. Composability is about services are effectively able to be composed and also participate in composition regardless of the size and the complexity of the composition. So service does not care or should not know about the size of the environment or the complexity of the environment. So their implementation is completely independent from the composition. It ensures the services are able to participate in multiple composition to solve multiple larger problems. That means one service can be used or used for different composition in different areas, and basically based on the functionality they provide. How we apply service-oriented architecture: in order to make sure we use or we follow certain acceptable standard, we need to have a mechanism to ensure that the service-oriented architecture is applied and managed in a proper standard way. We need to have a governance program. So the governance program is a program that makes sure people do what is right by the book. In conjunction with software governance, it controls the development and operations of softwares. The goal of that is to establish a service-oriented architecture organization governance that governs the SOA efforts and breaks down the capabilities into non-overlapping services. To do that, we need to have policies, and the policies we need to have for our governance, they apply to different layers of different types of software. So for different types of software and different service or different layers of service, we need to have different policies. We need to be codifying the law and regulations and incorporate the guidelines and the best practices into services. They must address all the stages of service lifecycle, so it has to apply the governance policies, has to apply in technology section, in design, development practices, configuration management, and so on. Then we use those policies in something called processes. So we need to have governing processes, and we use those policies that we have throughout the service organization for our processes. The processes we have enforce those policies. They are system-driven processes and then also human-driven processes. And eventually, as part of our governance, we need to have matrices. The purpose of having matrix is to measure our success in implementing correct architecture. So it measures the service reusability, it measures the compliance of the system with our policies and etc. It measures the organization itself, and also measures the governance program that run by SOA board. So if we look at our business capabilities, we can see those capabilities are exposed to outside world by the technical view. That means we create service interfaces technically and expose our capabilities to outside world. Then we have another side of this coin, which is the business services view. That means how our organization sees our services in terms of business operations. So the business operations, how they relate to our individual businesses, exposed by the technical view. The view of the business services are basically understood and implemented by service designers as a business service model. Then those business service models are handed over to enterprise architects, and the enterprise architect creates service specification model for those services, and then SOA board, which is the board that controls how technical view of our capabilities are actually matched and complying by the business service view. And that is all is enabled through usage of our policies, through usage of basic governance, through the usage of policies, standards, models, and patterns.